The last kinds of functions we need to learn how to take antiderivatives of in section 4.1 are the trig functions. So if you want to give yourself a quick pop quiz, see if you can write down the derivatives of the 6 trig functions. This would be a good time to pause the video and see if you can write them down. The derivative of sine x is cosine x. The derivative of cosine x, negative sine x. The derivative of tangent x, secant squared x. The derivative of secant x is secant x tangent x. The derivative of cotangent x is negative cosecant squared x. And the derivative of cosecant x is negative cosecant x cotangent x. Now, associated to each of these derivatives is going to be a corresponding antiderivative rule. For example, since the derivative of sine x is cosine x, the antiderivative of cosine x is sine x plus c. Put my dx in there. Similarly, the antiderivative of sine x is going to be negative cosine x plus c, and move the negative to the other side. The antiderivative of secant squared x is tangent x plus c. The antiderivative of secant x tangent x is secant x plus c. The antiderivative of cosecant squared x is going to be cotangent x plus c. And finally, the antiderivative of cosecant x, cotangent x, is equal to cosecant x plus c, negative cosecant x plus c. Oops, I lost my negative on that one also. So for the antiderivatives of cosecant squared and cosecant x times cotangent x, both of those have negatives in the antiderivatives. Now, these formulas are so important that I would tell you to memorize them before you watch the next video. So after this video ends, take a break, and make sure that you get all 6 of those antiderivatives memorized. Also, if you're rusty at all on the trig derivatives, you need to memorize those. One thing that people find a little bit confusing is the plus and minus signs when you're taking derivatives of sines and cosines. So some folks find this chart helpful. I'm going to write the function sine x, cosine x, negative sine x, and negative cosine x in a circle. And then if you go clockwise around this circle, that corresponds to taking derivatives. And if you go counterclockwise, or some people say anti-clockwise, that corresponds to taking antiderivatives. So for example, the derivative of sine x is cosine x, the derivative of cosine x is negative sine x, and so forth. Going in the other direction, the antiderivative of cosine x is sine x. The antiderivative of sine x is negative cosine x. Now, a couple of things that you might be wondering is if you scroll down this list, we see the antiderivative of sine x and cosine x, but for example, we don't see the antiderivative of tangent x, or the antiderivative of secant x. So what about those? Turns out we're going to have to wait to learn those antiderivatives because the answers involve the natural log function. And that's something that doesn't come until a little bit later in the course. So let's look at a couple of quick examples. These are both from the textbook. In problem number 30, you're asked to find the antiderivative of sine x minus 6 cosine x. And we'll just do that term by term. The antiderivative of sine x is negative cosine x minus 6 times the antiderivative of cosine, which is sine. So in that, I used the antiderivatives together with the constant multiple rule. For something only slightly more complicated, let's look at problem number 34. To use a different variable here. They're looking for the antiderivative of secant y times tangent y minus secant y. Here I see a product, and we note that there's not a product rule for antiderivatives, so I'm going to distribute just like I did with polynomials. I have secant y times tangent y minus secant y times secant y is secant squared y. And then notice that both of these antiderivatives are on our list. The antiderivative of secant times tangent, that's here. Notice with the variable change, the answer is going to be secant y minus the antiderivative of secant squared, that's this rule here. The antiderivative of secant squared is tangent, and I'm using an independent variable y instead of x. So secant y minus tangent y plus c.